Good afternoon. Today we will talk about peer production in radiology.
My group is conformed by...
Good afternoon, Lena Gonzalez.
Good afternoon, Lena Gonzalez.
Juan Avila Encineros speaks to you. And let's start with the introduction to the topic. The production of pairs in radiology is a phenomenon of interaction of X-rays with matter. It is the production of electropositron pairs. A photon that reaches the atomic nucleus can materialize in a pair of electromositron particles. The mass of each of these particles is equivalent in energy terms to 510 kiloelectron volts. So a photon will not be able to undergo this transformation if it does not have an energy minimum of 1020 kiloelectron volts. This energy is much higher than that used in diagnostic X-ray acids. Therefore, in the field of health, this phenomenon is relevant in the exchange with matter and producers. Now we will talk about the fundamental points for the production of pairs. The production of nuclear interaction pairs occurs when a high-energy photon interacts with the nucleus of an atom, resulting in the creation of an electron-positron pair. As a second fundamental element, we have the energy threshold. For pair production to occur, the energy of the incident photon must exceed the minimum threshold of 1020 kiloelectrovolts. And we also have the factors that can affect said pass production. We have the photon energy, which is the first point, the photon energy is a clinical factor, since it determines the probability and characteristics of the torque production process. And we have the geometry of the beam as another fundamental factor. The angle and kenigma of the photon beam can affect the spatial distribution and energy of the electropositon pairs produced. And as a third and final factor, we have the type of material that is used for the production of X-rays, which we can see in the table, that affects the amount of density, how effective it is, and the
On photon energy selection, which basically consists of carefully choosing the photon energy and its incident to maximize performance, production, and to immunize unwanted violations. We also have the use of AR conformation and polymation techniques to control the special distribution and size of the pairs of the toposintron produced. We have couple production, which is fundamental to the process behind PNT imaging, where positron annihilation and electrons are used to generate images of physiological processes within the body. Another point we have is the energy-dependent behavior of the production between the pairs to improve the contrast and resolution of dynamic techniques. We have radiation exposure, which is that the anti-energy buttons necessary for the production of pairs can pose potential radiation dispersion risks, so the human is very careful and must watch. And we have the loss and dispersion of energy in the wall. The pairs have replacement, produced, may experience loss and dispersion of energy, which can affect the production and resolution of practical applications of image clouds.
In conclusion, pair production is a complex process that depends on many factors. We will have a good resolution in the image or a poor resolution in the image.
Thank you very much for your attention.